All right, Algebra 1B students, welcome to part 1 of lesson 11.6. We're going to start talking today about what is known as inverse variation. Inverse variation is a relationship that we sometimes have between two variables, like a y and an x. It is not exactly like a linear relationship that we're kind of used to. It's also not a quadratic relationship. It's another type of relationship that a y variable and an x variable can have. And this comes about when the product of the two variables is a constant number. What that means is my two variables, y times x, if I multiply them together, they always end up being a constant number, some value k. So an equation that you can write in this form, x times y equals k, or y times x equals k, is called an inverse variation. Your book also will write it y equals k over x, and that just comes from dividing both sides by x. So any of those three ways that you want to look at it, they are all inverse variation equations. And this k value that we get when we multiply our two variables is called the constant of variation. That's k. This right here is the constant of variation. The constant of variation. The product of our two variables, x and y. What I'm going to ask you to do in your practice problems is to write these types of equations, x times y equals some number, given certain information about this situation. Okay? So most of these problems are quite simple. For example, this one, they say, suppose y varies inversely with x. That is a very important phrase at the beginning of all of these problems. Suppose that y varies inversely with x, meaning x and y multiply together to give you just some number that's the same every time. And y is equal to 8 when x is equal to 3. What is an equation for the inverse variation? And I am going to want you to write this actually two different ways. One where the x and y are together, and one where the y is by itself. We're going to start by using the general form of an inverse variation where we have x times y is equal to k. The problem right now is I don't know what k is. I do not know my constant of variation. But I do know an x value and a y value that I can put into this equation. So that is exactly what I'm going to do. Take x equals 3 and put it in here for x. Take y equals 8 and put it in there for y. And I end up with 3 times 8 is equal to k. Well, obviously 3 times 8 is 24. So my constant of variation, my k value, is just 24. Okay? So that is always the first step when you are trying to write an inverse variation equation, is to find your k value. Figure out what your constant of variation is. Once you know your constant of variation, writing this equation is very, very simple. Okay? And all we have to do is leave our x and y variable in the equation, x and y, so that we can put in whatever two numbers we would like, and say that they are equal to our constant of variation. There's option 1. And it's as simple as writing x times y equals whatever you get over here, or your k value. Then I also want you to write these equations where the y is by itself, meaning divide both sides by x here, and we write y equals this constant of variation number, 24, divided by x. Okay, so these are the two things that I would like to see whenever you write me an inverse variation equation from given x and y values. So step 1 is to find this k value over here. And then step 2 is just write me the equation in two different forms. Once with x and y together, once with y by itself, and x underneath the constant of variation. Okay? Now, I would like you to try with this information here, suppose that y varies inversely with x and y is 9 when x is 6. What is an equation for this inverse variation? And remember, I would like it in 2 different ways, please. Pause the video, take a look here at this problem, then come on back and I will show you what we should do. Okay, 9 times 6 is 54. So one version would be x times y is equal to 54. The other version, y equals 54 over x. Okay, easy enough. Writing inverse variation equations is not very hard. Not too hard at all, really. So the other thing that I'm going to ask you to do in your homework is to use inverse variation to solve certain problems, solve certain word problems in real life, in physics, and other subjects, and things like that. So here's an example from physics. The weight that is needed to balance a lever, which is exactly the sort of system we have here, 2 weighted objects on either side of a fulcrum. The weight needed to balance a lever varies inversely, there's our key again, varies inversely, with the distance from the fulcrum to the weight. How far from the fulcrum should the person sit to balance the lever? Okay? So we have this person. They weigh 160 pounds. We don't know how far away they need to be from this fulcrum, this balancing point here, but that's what we're trying to find. What we do know is that there is an elephant that weighs 1,000 pounds, and that's that elephant, looks like a she, I guess, wearing that pink flowery bow, is 7 feet away from the fulcrum. So we're told that distance and weight vary inversely in this situation. So what that means is my distance is like my x, and my weight is like my y. X times y is equal to k. So distance times weight always needs to be equal, needs to equal my k value. So I'm going to use the elephant to write an equation here, and then I will put in the information for the person and figure out what I need to. So distance times weight is equal to k, and the distance for the elephant is 7 feet, and the weight of the elephant is 1,000 pounds. So that's equal to k. Well, 7 times 1,000 obviously is 7,000, so my k value is 7,000. So that means that distance times weight for the 2 sides of this lever always need to equal 7,000. Okay. Now I don't know the person's distance, that's my x variable, so I'll just say d. But I do know the person's weight, that's 160. Okay, so the distance, however far away that they should stand, times 160 pounds needs to equal 7,000. Because the distance and the weight need to vary inversely. So if I divide 7,000 by 160 to get d all by itself, I get that d equals 43.75 feet. So that person should stand 43.75 feet away from the fulcrum on that very long and hopefully very sturdy plank or board or floor piece. Sorry, not 43.75. Okay, so we use one side to set our equation and find our constant variation, then we use that and some information from the other side to solve for what is missing. I would like you to try that with this problem about speed and time. Oh, sorry, distance and time. Time varies inversely with distance traveled. And our 50-mile trip took 3 hours. The question then is, how long would a 65-mile trip take in number of hours? Okay? Pause the video to take a look at this problem where you have, again, distance and time varying inversely. Try to figure out how long a 65-mile trip we'll take, and then come on back and I'll show you what we should get. All right, my constant of variation here is 150. So I know that distance times time needs to equal 150. So if I'm going 65 miles, there's my equation, and I'll divide by 65. And t equals 150 divided by 65, about 2.3 hours. 2.3 hours. Okay. If you have questions about writing inverse variation equations, finding the k value, or you have questions about any of the word problems that we've done or that I'm going to ask you to do, please ask me in class tomorrow. Otherwise, that's all I have for you tonight. Have a wonderful night.